Welcome to our third video explainer on plane geometry, focusing on collinear and coplanar points and concurrent lines. Our geometric blueprint follows a clear plan. We start with the building blocks like points, lines, and planes. Next, we explore the rules of construction, the postulates that govern our system. Finally, we use these rules to build and prove theorems, our finished structure. Let's organize our building blocks. So, what are collinear points? Well, points are collinear when they lie on the same line. Simple as that. How about coplanar points? Points are coplanar when they all lie in the same plane. That's it. Now, what will happen when lines intersect each other? Well, here is the answer. When lines cross paths, two distinct lines that share a common point are called intersecting lines. Also, concurrent lines are three or more distinct lines that pass through a common point. Concurrency is a special case of intersection for three or more lines. Another important concept is betweenness. The concept of betweenness is a cornerstone for measurement. For three collinear points A, B, and C on line L, B is between A and C if and only if AB plus BC equals AC. Yes, remember this always. We can apply our definitions to a geometric figure like this pyramid. We will identify collinear and coplanar points, concurrent lines, and an example of betweenness. Look at the figure. Can you spot them? Well, you should be. Here in the illustration, points B, E, and C are collinear as they lie on one line. Points A, C, and D are coplanar on a single plane, the triangular face. Line segments A, B, C, B, and DB are concurrent at point B. Feel free to pause the video and study the figure. The foundation of truth rests on postulates and theorems. A postulate is a statement accepted as true without proof, like the basic rules of a game. A theorem is a statement accepted only after it has been proven, a logical result derived from the rules. Here are 5 foundational postulates. They cover the existence of lines and planes, intersections, and the nature of space. These statements form the bedrock of our geometric system. You may pause the video, have a shot, and memorize these as possible. You need these geometric concepts as math majors. Let's explore these postulates one by one. Postulate 1 states that through any 2 points, there is exactly one line. Postulate 2 states that if a line contains 2 points of a plane, then the line is contained in that plane. This is why a tripod never wobbles. Postulate 4 states that if 2 distinct planes intersect, their intersection is a line, analogous to the corner of a room. Postulate 5 states that space contains at least 4 non-coplanar points, forming the simplest 3D shape. Using our foundational postulates and logic, we can construct and prove new truths or theorems. Theorem 1 states that if 2 lines intersect, their intersection is a point. We must prove this using our established rules. We prove Theorem 1 by contradiction. If we assume 2 lines intersect at 2 different points, it violates postulate 1, which guarantees exactly one line through any 2 points. Thus, the intersection can only be 1 point. You may pause the video and follow along with the proof. All in all, collinear and coplanar points are organized on lines and planes. Concurrent lines share a single point of intersection. Betweenness means the distance between collinear points is additive or could be added. Postulates are the foundational rules, and theorems are provable truths built upon them. Here is the summary of what we have covered today. Have a pause and take a shot. Thank you for watching this video. We hope this has been helpful. See you on the next one.